Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In today's video I will solve the next question, question number 6, related with exercise number 9.2, related with chapter number 9, differential equation. So let's move toward exercise number 9.2, FSC part 2 mathematics, differential equation, lecture number 11, chapter number 9. Question number 6 tells that find the solution curve of the differential equation xyy dash, which is equal to 3y square plus x square, which passes through the point -1 and 2. Move the solution. The first thing is that the differential equation is given, which is xyy dash, which is equal to 3y square plus x square. This y dash is actually called the first time derivative of y with respect to x. So we can write it xy into dy by dx. So because this is the first time derivative of y with respect to x, is equal to 3y square plus x square. Now we first convert this differential equation into homogeneous by dividing both sides with x, y. So xy cancel with xy, so we left with dy by dx on the left hand side of the equation, and over here y is cancelled with one of the y, so in the numerator we left with 3y, and in the denominator we left with x, and over here one of the x from x square cancelled with this x, so we left with x in the numerator and y with the in the denominator. Now over here this is actually the homogeneous form, so using substitution later y is equal to vx. So dy by dx will be equal to, taking the derivative, so product according to product rule, it become v plus x dv by dx. Now by further simplification, this differential equation will become dy by dx is v plus x dv by dx, v plus x dv by dx, which is equal to 3y by x. So 3 y by x, from over here y by x is v, so put y by x v, so it becomes 3v, plus x by y is the reciprocal of y by x, so it means it will be 1 over v. So after this it become x dv by dx, shift this v on the right hand side, it become negative v, so 3v minus v will be 2v, and plus 1 over v. Now after this over here I taking LCM, so it become x dv by dx, will be taking LCM v, so we left with 2v square plus 1 in the numerator. After this using separable differential equation, shift dx and x on the right hand side, it become dx by x, and shift this value on the left hand side, so these both will reciprocate, it become v over 2v square plus 1 into dv, taking indefinite integral on the both sides. Over here, if I suppose this 2v square plus 1 is equal to any variable, let I suppose it 2v square plus 1 is equal to t, and if I take the derivative of this t with respect to v, it will give us dt by dv, it will give us 4v, and this gives us 0 because it's a constant. In the numerator I need v dv, so shift dv on this side and 4 on this side, so dt by 4 will be v dv. After this it become v dv is actually dt by 4, so dt by 4 integral v dv is dt by 4 and 2v square plus 1 I suppose t, so it become 1 over t is equal to the integration of dx by x is ln x, and with constant I can write ln because it will give us still a constant. After this 1 over 4 will come down outside of the integral, and 1 over t integration is ln of t, which is equal to, over here the product rule will be used, so it become ln cx. So 1 over 4 ln of t I suppose 2v square plus 1, 2v square plus 1 is equal to ln of cx. Now shift 1 over 4 to the power, so it become ln of 2v square plus 1 to the power 1 over 4 according to the property of natural logarithm ln of cx. Taking exponential on the both side, so they cancel with each other, we left with 2v square plus 1, v is actually y by x, so it become 2 into y square by x square because v is y by x, so 2 y square over x square plus 1 raised to the power 1 over 4 is equal to cx. So now this curve is actually passing through the point -1, 2, so I solve it further. Now we get this differential equation, this is not differential equation because there is no dy by dx over here. So this is the equation general, 2y square over x square plus 1 whole raised to the power 1 over 4 is equal to cx. So taking this out, so it become 2y square over x square plus 1 whole raised to the power 1 over 4 is equal to cx. So this curve is passing from -1 to -1 is x and 2 is a y. Putting these values over here in this equation, so it becomes 2 into y by x whole square. We can write it. So y is 2, so 2 by -1 whole square, y is 2 and x is -1, so -1 whole square, and plus 1 and whole raised to power 1 over 4 is equal to cx. So x is -1, so it becomes minus c. 2 over -1 gives us -2. -2 whole square, it will give us positive 4 because the power is even. So 4 into 2 will give us 8. 8 plus 1, it will give us 9. So 9 power 1 over 4 is equal to the negative c. So shift this negative on the left hand side, it becomes c is equal to minus time of 9 power 1 over 4. So 9 power 1 over 4 can be written as 3 power 2 into this 1 over 4 can be written as 1 over 2 into 2. So this 2 is cancelled out with 2, we left with c is equal to minus 3 power 1 over 2 can be written in the form of under root. So c is equal to minus under root 3. Now by inserting this value, it will give us the required equation. So from over here it become 2y square over x square plus 1 whole raised to the power 1 over 4 is equal to cx. So c is minus under root of 3. So minus under root of 3x. So this is actually the required curve, which is actually find out from this xy dash is equal to 3y square plus x square and passing through the point -1, 2. You can also simplify it further by taking the power 4. So taking the power 4, so over here it becomes 2y square over x square plus 1 is equal to minus under root of 3 into x and whole raised to the power 4, and then simplify this curve for y. So this will give us the required solution in term of y is equal to in term of variable x. So you can write it in this form. This is the simplified form. So with this question I finish my lecture. Thank you for watching. Subscribe my channel and also hit the bell icon to receive the upcoming notification and interesting problems and numericals related with calculus, linear algebra, computation, probability and statistics. Thank you.